Okay, so we're diving into this whole world of generative AI and how it connects with Python.
Sounds exciting.
It is, right?
Yeah.
And I think you're already ahead of the game just by wanting to learn about it, but this is going to be like your ultimate guide to understanding generative AI without all the jargon, you know?
Yeah, for sure. A jargon can be a real roadblock.
Exactly. You sent over Python for generative AI.pdf. So we're going to unpack all of that, what it is, how it actually works,
Right.
different types, and then also, most importantly, like what it can do in the real world, you know?
Well, that's what's so cool about generative AI. I mean, it goes way beyond just analyzing data, right?
Right.
It's like instead of teaching a computer to just read, you're teaching it to write, like compose music or design a product,
Yeah.
even write code from scratch.
Yeah, exactly. It's not just recognizing patterns.
Right.
It's like actually making something brand new. And, I've always been fascinated by AI art.
Yeah.
And that's actually mentioned in the source material about how it's being used in art and design.
Absolutely. It's already making waves. Like, there was this recent case, a generative AI created a piece of art that ended up being used in a major fashion ad campaign.
Right.
It wasn't just copying existing styles.
No.
It was generating something totally fresh based on prompts from the designers.
Whoa, that's crazy. It makes you wonder what the future holds,
Right.
like for artists working with AI.
Yeah, totally.
But let's back up a bit.
Okay.
How does generative AI work?
Sure.
I keep hearing this term generative models. I'm not going to lie, it sounds a bit intimidating.
Think of it like this. A generative model is kind of like a master chef who has learned from, thousands of recipes. But instead of just following those recipes, the model can take inspiration from them to invent entirely new dishes, like blending flavors and techniques.
Okay, so it's like learning from data,
Yeah,
but then it goes beyond that to make something new.
exactly.
And the source material talks about machine learning and deep learning. Can you break those down for me a little bit? I know deep learning has something to do with neural networks, but I'm still a little fuzzy on like the specifics.
Sure, yeah. Deep learning is a type of machine learning that uses these artificial neural networks, which are really just complex systems of these interconnected nodes. And these nodes, they pass information between each other, kind of like neurons in your brain.
Okay.
And as you tweak the strength of the connections between these nodes, the network actually learns from the data.
So it's building its own understanding, like it's making a mental map of all those recipes, like in your Master Chef example.
Exactly. And what's really neat about deep learning is that as you feed the network more data, the better it gets at like understanding those patterns and relationships in the data.
Okay.
It's this learning process that allows generative models to create such impressive new content.
Got it. So you've got these generative models powered by deep learning. They're learning from all this data.
Hmm.
But then the source material throws out all these different types of generative models: VAEs, GANs, autoregressive models, flow-based models. It's like a whole alphabet soup of acronyms.
Yeah, I hear you. It can be pretty overwhelming at first. Each of those models, though, they have their own strengths and weaknesses, so they're good for different tasks.
Okay.
Think of them like different tools in this like creative toolkit.
Yeah, that's a good way to think about it.
So, variational autoencoders, or VAEs for short.
Okay.
They are really good at compressing data into a smaller representation and then reconstructing it.
Good.
Kind of like creating a blueprint from a really complex structure and then using that blueprint to build, a new structure that captures the essence of the original one.
So it's like capturing the core features
Yeah,
and then using those to generate something new. That sounds pretty powerful.
it is. And VAEs are really well suited for image generation specifically because they can learn to encode these key features of an image, like the shape, the color, the texture, into that smaller representation, and then use that representation to generate new images that share those same features.
That makes sense.
All right.
What about those other models, though? GANs, autoregressive models, flow-based models. What sets them apart?
Well, generative adversarial networks, or GANs, are probably the most well-known. They're known for making those crazy realistic images and videos. Imagine like a game of cat and mouse between two AI systems.
Okay.
One is like a forger trying to create these fake masterpieces,
Okay.
and the other one is an art expert trying to spot the fakes.
Right.
The more the forger practices, the better the fakes get.
Right.
And the more the expert scrutinizes, the better they get at spotting these little inconsistencies.
So they're like pushing each other to improve.
Exactly.
And that's how you get these mind-blowing results.
Yeah.
But you mentioned those other models too.
Yeah.
Autoregressive models and flow-based models. Where do those fit in?
Well, autoregressive models, they are fantastic at working with sequential data where the order of elements matters.
Okay.
So think about things like composing music note by note or generating text like word by word.
It's like predicting the next word in a sentence.
Yeah.
Exactly. They learn the patterns and then use that to generate new sequences that follow those same rules.
Okay, that makes sense. And what about flow-based models?
Flow-based models are a little more on the complex side, but they're really good at capturing the underlying structure of data.
Okay.
So you get more precise control over that generation process. They're really useful for tasks like density estimation and generating high-quality samples from complex distributions. Think of it like sculpting a complex 3D object. You can precisely control the final result.
Okay, cool. So Python keeps coming up. The source material really emphasizes its role in generative AI. Why is Python such a big deal for AI?
I think it's mostly because it's so simple and versatile.
Okay.
It's really easy to learn, even if you're a beginner.
Yeah.
And it has this huge ecosystem of libraries and frameworks specifically designed for AI and machine learning.
So Python's like the go-to because it's user-friendly and it has all these powerful tools.
Exactly.
The source material mentions libraries like TensorFlow, PyTorch, Keras.
Are those the workhorses for building these generative models in Python?
Absolutely. TensorFlow and PyTorch are like the foundation of your AI workshop.
Okay.
They provide the building blocks for training these complex neural networks that we were talking about.
Right.
Keras then kind of sits on top of TensorFlow and makes it even easier to use.
Okay.
It's like having a set of pre-built components you can assemble into your own, AI creations.
And I see other names popping up. NumPy, Pandas, Matplotlib, Seaborn. What do all those do?
Think of those libraries as your data wranglers and your visualization wizards.
Okay.
NumPy and Pandas are your go-to tools for manipulating and analyzing large data sets.
Okay.
You got to get your data into the right shape and format for those AI models.
Right.
And Matplotlib and Seaborn, they're all about making sense of your data visually. They help you create those graphs and charts to understand your data.
So it's like having a team of expert assistants to help you manage and understand the data, which is so crucial for AI.
Yeah, exactly. They just make the whole process so much smoother.
Okay, so it sounds like Python really is the key.
Uh-huh.
But let's get down to it. Let's get practical. The source material actually walks us through building a generative model. What's the first step?
Before you can even think about building a model, you got to prepare your data.
Okay.
Like prepping ingredients before you start cooking. Data preparation that involves loading your data set, cleaning it up, and getting it into a format your model understands.
The source material uses the MNIS dataset as an example.
Right.
It's all those handwritten digits, right? And they talk about normalizing pixel values and reshaping the data. What's the point of all that?
It's all about getting your data ready for your model to learn effectively. Normalizing pixel values, make sure that they're all within a specific range.
Okay.
It's easier for the model to process them. Reshaping the data organizes it into the right structure for the model to understand. It's like if you were trying to teach someone to recognize letters, but you're showing them the letters all jumbled up. It wouldn't make much sense.
So data prep is like organizing your workshop before you start building.
Yeah, exactly. And once your data is all prepped and ready, you can start building your model.
Okay.
The source material gives an example of building a VAE
Okay.
using TensorFlow and Keras.
Cool.
It's a great place to start.
I'm excited to actually see some code. Can you walk me through how a VAE actually works?
Sure. So a VAE has two main parts, an encoder and a decoder.
Okay.
Think of the encoder like a master organizer taking a complex input, like an image, and compressing it into a smaller, more manageable representation.
So the encoder is kind of like condensing a complex idea into a concise summary.
Exactly. And that compressed representation is called the latent space.
Okay.
And that's where the magic happens.
Got it. So what happens next?
Then the decoder comes in, and it takes that concise summary from the latent space.
Okay.
And it tries to reconstruct the original input. It's like taking a set of blueprints and then rebuilding the original structure.
Yeah.
And the whole system is trained to make the difference between the original and the reconstruction as small as possible.
So the decoder is like a skilled architect, taking those blueprints and recreating the original image.
Exactly. And by going through this process of encoding and decoding, the VAE gets the ability to generate new images that look like the ones it was trained on.
That makes sense.
Yeah.
Now, I'm seeing this term reparameterization trick in the code.
Oh, yeah.
What's that all about?
Ah, the reparameterization trick. Sounds fancy, but it's really just a clever way to solve a problem. Remember how we talked about the VAE encoding information into the latent space?
Yeah.
Well, to train the model, you have to sample from that latent space randomly.
Okay.
But the typical way of randomly sampling, that doesn't work well with the way neural networks learn.
Okay.
It's through a process called backpropagation.
Backpropagation. Can you remind me how that works again?
Sure. So backpropagation is how neural networks learn from data. It's all about calculating the error the network makes and then adjusting the connections to reduce that error.
Okay.
Think of it like fine-tuning a musical instrument,
Right.
making little tweaks to get the perfect sound.
So the reparameterization trick helps make random sampling and backpropagation work together.
Yeah.
How does it do that?
Well, it introduces a function that lets us sample from the latent space in a way that works with backpropagation.
Yeah.
It's like we're adding a special adapter so it fits.
Okay, very
Yeah.
clever. It's cool seeing how these models work. But you also mentioned that we're going to be building a GAN,
Yes.
and that's the one with those two competing networks. then.
Exactly. And the example code shows you how to build a simple GAN using TensorFlow and Keras. Remember that forger and art expert analogy.
Yeah.
So in a GAN, the generator network is the forger, and it's trying to create realistic images from random noise. And then the discriminator network is the art expert, trying to tell the real from the fakes.
So it's this constant battle between the two.
Exactly.
The generator's trying to fool the discriminator, and the
Yeah.
discriminator's trying to stay ahead.
Exactly. And as they train together, both networks get better at their jobs. The generator makes more realistic fakes. The discriminator gets better at spotting them.
And that's what leads to those amazing results.
Precisely.
This is so fascinating. We've already covered so much
I
today.
know, right?
We talked about what generative AI is, how it works, explored different types, and even peeked at the code.
Yeah.
I feel like an AI expert already. What else does our source material have in store for us?
Well, now that we've got the basics down, the source material actually gets into some more like advanced techniques
Okay.
and architectures. Things like conditional generative models,
Okay.
style again, and then even some enhancements for VAEs. It's like leveling up,
Okay, yeah.
from building a basic birdhouse to a skyscraper.
Stylegan. I like that name. It reminds me of those like AI-generated fashion models I've seen.
Yeah.
Is that the same thing?
You're right on the money. Style again is all about like manipulating the style of generated images.
Okay.
It's a GAN, but it gives you this crazy level of control over the features. You can tweak things like, facial expressions, hairstyles,
Wow.
even the whole artistic style.
So you're saying instead of just generating a random face,
Yeah.
I could like tell it, give me a picture of a person with curly red hair and blue eyes, and it would do it.
Yeah, precisely. You can get super specific. And that opens up so many possibilities, like in fashion, advertising, even entertainment. Imagine making images of models in different outfits without a photo shoot, or making video game characters with like really specific features.
Yeah, that's crazy. You could change so much.
Right.
What about those conditional generative models? You mentioned those earlier. What makes them different?
So conditional generative models, or CGMs, let you generate data based on, conditions.
Okay.
Imagine giving a CGM a text description like a fluffy cat wearing a top hat and riding a unicycle. And then it actually generates an image that, matches.
Whoa, that's wild. So it's like you can give it creative prompts.
Exactly.
That could be super useful.
Yeah,
Like, I don't know, image captioning or creating art from descriptions.
you got it. CGMs connect different types of data like images and text.
That's pretty amazing.
And our source material also mentions like advancements in VAEs, going beyond images to explore things like disentangled representation learning.
Disentangled representation learning. Okay, that one sounds a little complex.
Yeah.
Can you break that down?
So imagine training a VAE on images of faces, right?
Okay.
If the VAE learns disentangled representations, it can separate features like hair color, eye shape, even like facial expressions. And then you can manipulate those features independently.
So you could make a face with brown hair and green eyes and, I don't know, a big smile.
Yeah, exactly. It's like having these sliders for each feature, being able to like disentangle and control all those different features. It's a big deal. But even with these, even with these advanced models, you have to train them properly to get good results. And the source material talks about things like data augmentation.
Right. Okay. I
Yeah.
remember seeing those terms.
Yeah.
Data augmentation, hypoparameter tuning.
Eh.
They sound kind of intimidating, though.
Well, data augmentation is actually a pretty cool technique.
Okay.
It can boost the performance of your model, especially if you don't have a ton of data.
Okay.
It's like creating variations of your existing data to expand your training set. Think of it like showing your model different views of the same object,
Okay.
like rotating an image, flipping it, adjusting the brightness.
So you're giving it different perspectives to help it learn more.
Exactly. This helps it generalize better, like teaching a kid to recognize a cat by showing them pictures of cats in all kinds of different ways.
That makes a lot of sense. What about hyperparameter tuning? That was the one about finding the best settings, right?
Yeah, hyperparameters are like the settings for your model. They control things like the learning rate, how quickly the model learns,
Oh, yeah.
the number of layers in your neural network. That's like how complex the model is. And the activation functions,
Okay.
how the nodes process information.
It's like fine-tuning the engine of a race car.
Yeah, exactly.
Got it. But how do you know if the model's any good after you train it? I mean, how do you evaluate something that's creating something completely new?
That's a good question. Evaluating generative models, it's a little trickier than evaluating models that make predictions, you know?
Right.
With generative models, you're not just looking for accuracy, you're also looking for quality, diversity, realism.
So it's not just if the model can make something that looks like a cat.
Yeah.
It's whether it can make different types of cats in different poses,
Yeah.
all looking real.
Exactly. You want it to be, believable. And the source material talks about two ways of evaluating: qualitative and quantitative.
Okay.
Qualitative is looking at the samples and judging them based on, like, human perception. It's like having an art critic judge a painting.
Okay, but that seems like it could be kind of subjective.
Yeah, you're right. It can be.
What about quantitative? How does that work?
Quantitative is using metrics to measure specific things.
Okay.
One metric is the inception score, or IS, which measures how well the generated images align with, like, pre-trained image classification models.
Okay.
The idea is if they're realistic and diverse, they should activate the same neurons as real images.
So it's like seeing if the AI can trick another AI.
Exactly. And then there's the Frechette inception distance, or FID, which looks at how similar the distributions of real and generated images are.
So it's like checking if the generated images have the same kind of style and feel as the real ones.
Exactly.
So having both types of evaluation, that's important for getting the whole picture.
Absolutely. It's like having feedback from an art critic and a statistician.
I like that. It makes it seem less complicated.
Yeah.
But at the end of the day, it's about how well this tech works in the real world, right?
Right.
And our source material has a lot of examples of how it's already making a difference.
It really is. I mean, it's impacting everything. How we design things, create content, diagnose diseases, even how we experience entertainment.
Yeah, that's amazing. It really is like we're at the beginning of a technological revolution.
I think so too. And the source material mentions some of the trends that are shaping the future of generative AI.
Okay.
Like right now, there's a lot of research into models that can generate, dynamic content like videos and animations.
Whoa. So instead of just making still images, it's AI that can make moving pictures.
Yeah, exactly.
Uh-huh.
Imagine AI making characters and environments for virtual reality, or even personalized videos that adapt to how someone learns. There are so many possibilities.
It's crazy to think about how much this could change things. It's like we're just getting started.
I think so too. As these models get better and easier to use, we'll see even more applications we haven't even thought of yet.
It's amazing. But here's a question that's been on my mind. If generative AI gets so good that we can't tell the difference between what it makes and what humans make, what does that mean for creativity?
That's a really deep question, and I don't think anyone has the answer yet. It makes us think about what it means to be creative, what it means to be human. How do we relate to technology that's starting to copy us?
It's definitely something to think about as things keep changing so fast. This deep dive has really opened my eyes to generative AI.
Yeah,
I went from feeling a bit intimidated by it to being fascinated.
that's great.
It's incredible.
I think the main takeaway is that generative AI is a tool.
Okay.
And like any tool, it can be used in good ways and bad ways. It's up to us to understand it, use it responsibly, and make sure it helps us.
That makes sense. It's been awesome exploring the world of generative AI with you. I feel like I've learned so much,
Me too.
and I'm walking away with even more questions.
That's good though, right?
I think that's a good sign.
Yeah, it means you want to keep learning.
Exactly.
And with generative AI, we're really just at the beginning.
Yeah, it really is a fascinating time to be following all this. And you're right, the source material digs into how generative AI is changing all kinds of different fields.
Mm-hmm.
We were just talking about entertainment, but healthcare is another big one.
Yeah, healthcare is definitely one I was curious about. It just seems like it could make a huge difference there.
Totally. The source material specifically mentions medical imaging and drug discovery.
Okay.
Like, imagine training a generative AI on tons of MRI scans.
Okay, yeah.
It could learn to spot tiny things that doctors might miss,
Yeah.
helping diagnose conditions earlier.
That's amazing. Like having an AI double checking everything.
Exactly. And then in drug discovery, generative AI is being used to, like, design new molecules that have specific properties,
Oh.
which could really speed up, developing new drugs and therapies. It's incredible to think that AI could help make those breakthroughs happen. Makes you wonder what else is coming.
The source material also talks about the art world, right?
Oh yeah, the art world is being totally shaken up by this. Generative AI is being used to create completely new types of digital art, help artists in your process,
Hmm.
even compose music.
Yeah, I've seen some of that AI art online. It's really impressive.
Right. It's like the AI has its own creative energy,
Right.
and some artists are even like working with AI as a partner
Wow.
to come up with new ideas and, push their own limits. It's leading to some really cool stuff.
It does feel like a whole new kind of art is emerging, humans and AI working together.
Yeah.
But stepping back a bit, what does the future hold for generative AI?
Well, it's definitely not just a research thing anymore.
Right.
It's moving into the real world fast. It's changing how we do everything.
It is kind of overwhelming to think about how big of an impact it could have. It feels like a turning point. I agree. And the source material talks about some of the things that are shaping the future. For example, we're seeing research on models that can generate dynamic content, like videos and animations.
Oh, wow. So instead of just pictures, we're talking about AI that can create, like, moving visuals.
Exactly. Like imagine AI creating realistic characters and settings for virtual reality or personalized videos that adapt to how you learn. So many possibilities.
It's hard to even wrap your head around it. But I have to ask, with generative AI becoming so good at making things that look like humans made them, what does that mean for our own creativity?
That's the million-dollar question. I don't know if anyone really knows yet. It really forces us to think about what it means to be creative, to be human. How do we fit in with this technology?
Yeah, it's a lot to think about as things keep changing. This deep dive has been amazing. I
Yeah.
feel like I had a lot to learn going into it, and now I'm just fascinated.
I'm so glad to hear that. I think what's important is that generative AI is a tool. And, like any tool, it can be used in good ways or bad ways. It's up to us to make sure it's a force for good.
That makes a lot of sense. Thanks so much for taking us on this journey into the world of generative AI.
It's been my pleasure.
I feel like I've learned a ton and still have so many questions.
That's how you know it was a good deep dive.
Exactly.
It means you're ready to keep learning, and the possibilities are just opening up with generative AI.
I can't wait to see what happens next.